Welcome, my amazing little cupcakes. Okay, I'm never gonna call you that again. It's just too much cringe. Um, this is what we got last time. Enemies are shooting now. We get, uh, we can actually get damaged. As we can see, we can disappear, and everything is fine for now. So what we were thinking is, if I remember correctly, is adding like an overlay, some way to display stuff on the screen like health, I don't know, current power up or something, or at least, simply like fading the screen if we are dying or something. I'm sorry I didn't post in like a few days. Guys, I'm not dead. I know you were extremely worried about me, but don't worry, guys, I'm alive. Actually, for the next few days, I'm not gonna post every day, so, don't call in the police to do, maintenance checks, or how, I'm not sure how they are called, like well-being checks or something. I don't know, man. So let's actually talk about this shitty game. We, the way I'm thinking we should make this is we can add in like a few layers of things that are displayed on the screen. And so if I open in TL Draw here, we have the screen, which this is the scene basically, right? Okay. Excuse my, oh my, okay, that's illegal. Okay. We have the scene, and on top of the scene, we will have a bunch of other stuff, right? Which I'm thinking we can call these, I don't know, like overlays or something, right? Overlays. And we can have multiple overlays in our scene, right? Obviously, we can have multiple scenes. Those scenes can have multiple overlays and so on. So this is what we are going to implement. Again, these overlays will also tick and will also render, right? And we will have like a mechanism to control these from within our game objects. Okay, from using our scene primarily. So let's go ahead and do that. At some point we will need to change the scenes, so we will have multiple menus, right? And each menu will probably be a separate scene with different overlays, and so we will need a way to change the current scene. You can think of it as in how Unity is doing it, but we are implementing it from scratch. So let's do that. Let's see, how do we want this to look like? If we go inside the scene, we see here we have a vector of game objects. Let's also have a vector of overlay, or we should call this UI overlay, because it's for UI purposes. And I would also like to, if we are here, I would like to address something. It just occurred to me that whenever we are creating an object, like a new entity, right? Whenever we are removing an entity, we are allocating and we are deallocating memory. Okay, so if we see all the references for this add function, it takes in a pointer. So obviously here we allocate a new explosion particle. We allocate a new enemy projectile, and I just want to tell you that for our game, for our little game that we are creating, this is perfectly fine. Okay, we will never encounter an issue with this within the bounds of the scope that we have. with the game. So just a normal game that, it's not that complicated anyway. It's just, an example project, so you know how the architecture of a game would look like if you're implementing it from scratch. Obviously, we don't take into consideration the graphical part, which we will at some point in another series. Probably we will implement a UI library from scratch just so you can see how we can do it. However, this is not the way you should be doing things. You should not allocate entities in this manner, like allocating memory for each and every entity. And then when you remove an entity, you shouldn't deallocate that memory. And I'm saying you shouldn't as in talking about like industry standard projects. Okay, this is not good practice. I'm not trying to popularize this approach of allocating 100 things per frame and then deallocating 1,000 things per frame and stuff like that. That is slow, and at some point it's gonna bite you in the ass. But for our small project, this is gonna be enough. So don't worry about these allocations. Yes, it's not good practice. It's not ideal. We can go around and change this in the future if we really want. There's no need for us to allocate this every time. And the easiest approach that we could make is really we could pre-allocate like 100,000 entities or something like that. And whenever we want to create one, we just allocate some space in here, and then we just get a pointer to that entity. And whenever this entity goes dead, right, it's deleted, this is marked as free again, and so we can insert another entity here as well. And this is like the easiest thing that we could do, and this will lead to way less allocations, right, because we had one big chunk allocated already, and so we are simply only working in here, which is extremely fast. But for now, we are going to keep it even simpler than that. We are simply going to allocate memory for these objects, and we are going to deallocate those. If we are going to work on bigger projects in the future, then we are going to see the other approach, probably, or we could explore other approaches as well. The thing is, for now, this is okay. Okay, just letting you know. Usually, it's not a good thing to allocate and deallocate things as much as we are doing. Well, as much as we are doing is fine, but exponentially higher than this is pretty bad. So yeah, just so you keep that in mind, that could lead to performance issues in the future. So now that we got that out of the way, getting all the drama out of the way, so the programming community doesn't kill me, overlay. Not that I would care about it anyway. We are making things work. Okay, as long as they are working and we don't have performance issues, it means it's okay. All is good. All is good. Okay, we have overlays right here, and we are simply gonna do let's create those here for now. Overlay, and they're gonna have they're gonna actually, you know what, since we want to be able to do stuff to certain overlays, we should actually map these to some name, like that. So we should do that. In here we should have a function like tick and render, and obviously this is virtual, and by default they'll be empty. Let's create let's create a source file for these. UI overlay .cpp, and let's create actually a header if we are here, just like that. Okay, Let's do pragma once, our favorite keyword. Okay, let's go into the scene. Let's actually put this here. Let's go into the scene, copy paste this, just like that. Nice. And now we can, we could simply say, hey, there is something called a UI overlay, and we don't even need to include it. That's okay as well. Now this basic overlay will only actually have well, interesting. What do we want overlays to have? For now, nothing, I think. This might change in the future. For now, let's just keep these as simple as possible, as you should always. Don't forget about that. If you have to keep in mind something, guys, keep in mind the fact that you should code things as simple as possible. So we have here UI, okay, overlay, remove the pragma. Okay, so by default, UI overlays will be empty. Now, we could put all the overlays here, whatever, we don't really care. It's just an organizational thing. So we want an overlay for our in-game stuff, so like the HUD. And what do we want to display on the HUD? Well, I'm not sure. Do we have something in here? Well, I see we don't really have any health textures. I might need to go grab some of those. Oh, no, we have UI objects. What am I talking about? So we have player life icon. Nice. So we have a life icon. This is power. Okay, so this is how it looks like charged, I think. This is how it looks when it's not charged. Full plus empty. And this is the start button. Okay. So we have a few things. We also have like a font. Okay, this is interesting. Item held box. Yeah. Okay. So this shows what we have currently on our character. Yeah, sure. Why not? So let's keep it simple. Let's call this a like the HUD overlay. HUD overlay. And let's extend this UI overlay. And we could simply override these like that. Okay. And I think we will need a couple of things when we initialize this. Well, first of all, the HUD overlay needs to know how much health does the player have. And so when the HUD overlay is created, it needs the player to be alive. But you know what? It doesn't mean we have to pass in the player. What we could do is actually pass in the scene. And we can just forward declare here the scene. And we could just pass in the scene to everyone. So we could have it here as a protected thing. Scene, scene. And we can actually take in the constructor this. Just like that. So we are doing this. And mScene will be scene. Okay. Now obviously this will also happen with the HUD overlay. So let's do that. Okay, here we will call UI overlay, our base parent, our parent constructor, base constructor, I guess. These C++ namings are crazy, guys. I'm just telling you. Okay, so from here we can actually check how much health does the player have, and for the health it has, we can display these little icons. So let's actually do that. So let's copy this. Let's load in the asset for that. Okay, just like that. Actually, we can just do that. And we need here the correct name. Man, I always feel so, what's the word, like claustrophobic? So player life icon. You can have here player life texture. Oh, just player life, it's okay. And this is not actually an animation, this is a texture. And we just load the whole thing. Do we have somewhere where we load the whole thing? I think the default function is doing it, yeah. So it should be okay, just like that. So we should have this loaded. Okay. Let's do the following. We will need to initialize here a texture like mPlayer health texture, and it's gonna be assets, and we have to include that, and we will do assets get texture player life. Also we need to do to put this somewhere. So this is a texture detail. I don't know why it thinks it knows where it is, because it doesn't. Texture details. Just like that. And so what we can do now is say, hey, we simply put the render logic in here. Well, if we don't have a player, then we can just skip the rendering, I suppose, for now. So mScene get, yeah, right, we have to include a scene, so we get the auto completion and it can actually build. Get player. So just like that. And yeah, we can make, you know, things prettier, like we can make the player like a shared pointer, and we can use like a weak pointer, and we could see if the player was actually destroyed in the meantime. But guys, it's gonna work, trust me. We are not doing things, you know, multi-threaded, so we are not expecting this object to be destroyed in an unexpected time, let's say. And so this is extremely predictable. What's gonna happen? Worst case, the player is gonna be destroyed before we reach the render function, and guess what? That gets handled in the ticking phase, and then the render phase comes in, and the player will actually not pass. We will not pass this condition. We will return, and everything is gonna be all right. So if we are here, it means the player is valid. Nice. Okay, so far so good. What we want to do now is actually do for all the health the player has, which is not a lot, I think. Player, we have to include that. M health. Okay, that's not it's not accessible. What we could do is go into I think it's entity.hpp. This actually has this health, which is a float, which I don't actually like right now, because we know so if we have the health as icons, it means you get damaged. You're not gonna get damaged like 0.2 or 0.5. You're gonna get damaged like 1 at a time probably, or worst case scenario more than 1. And so I think it's okay to keep these as integers, to be honest. And this is going to complain at some point because we changed this declaration, but I'm going to live with that. We could also make this protected public I meant, or we could just provide a int get health function, which is simply going to return the health. But let's implement it in the health entity.cpp file, which we actually have. Well, let's put it in here. Let's correct this also. And yeah, we could just make that. So we could actually avoid calling a function. Let's make this a const because it's a getter. And so we don't actually change the class when we call this function. That's what that meant. And it's just a compilation thing. It's not going to restrict you from doing anything actually. We return the health. And so I forgot what I was saying. Well, if it's important, I'm gonna remember. Oh yeah, so we could just take this field as it is and use that, but I don't know, it's sort of cleaner this way. And I know I'm mixing up clean things with unclean things, but you do this however you want, really. It's just up to you. So this is get health, which we cannot call for some reason because there's probably some issue here. Bingo. Well, we also have it here. Like that. Player. In here, we changed the float to an integer. UI overlay.cpp. Okay, so this should be good actually. Maybe it's gonna take a bit. Game object. No. Oh, right. So why does this return a game object instead of a player actually? That's very weird. We should return a player because we know we are always gonna get a player, so no reason to do that. And we can just say there is a player somewhere, and this is also a player, and that's it, really. And this also needs to include, actually we don't need to include that. We need to include string, I think. Yeah. And map. Over here, nice. So in here, now everything is fine. Hopefully, we will see. So now when we do that, we can just render the health onto the screen, which is this. So we can do draw texture, and we don't really need to do anything special. We can just give in the texture as it is. That's not good. I think we need a pro version because we need to resize it. So we have this, we have the source. Now the destination is what we want to change. Now rectangle destination. Now where we want to put this, well, let's say for now 32 by 32 x and y. So it's going to be somewhere in the corner, right? And this is the starting position. Now, obviously, as we put in more health, we have to offset that position. So I'm going to show you what I mean in just a second. Let's do the width and height. Let's keep them 32 by 32. Actually, doesn't look that bad, I think. So let's use this destination here. The origin is going to be 0, 0. We don't care. Rotation is going to be 0, and the tint is going to be white. So what's going to happen now is we will have all the textures rendered at the same position, okay? Because we didn't change this at all. They are all rendered at the same X and Y. And I'm going to show you in a second what we're going to change. It's very simple. And you're going to reuse that in a bunch of places in your lifetime as a game developer, if you are interested in that. But first, let's go into the scene.cpp. And here, let's render the overlays after we rendered the game objects. So we do overlay, UI overlays. And this I think, because this is a map, we actually get here a pair of key and value, and we care about the value, which is second, right? We have here like a struct, which is a pair, and we have the first is a string, right? And the second is a UI overlay. Okay, so why is this? This is like that because in the scene we created this as a map, and when we iterate the map using this for loop, this form of the for loop, we are actually gonna get in the overlay a pair like this. And this is how the structure looks like. We have first is the key, which is a string, and the second is the actual element that we put in, which is an overlay in our case. In our case, you like my little accent there? A little accent. So yeah, whatever. Let's just do render like that. And it simply doesn't know, I think, what's an overlay. And I was right. Okay, so this also has to be a player, by the way, like that. Let's get on. Okay, so we render all the overlays. Now let's tick the overlays after we tick the entities. And this is delta time. And we should be pretty close to being done. Now we need a way to add this overlay. So let's create here a void add overlay. We're gonna give it a name, string, well, const string reference name, okay, UI overlay, So when we go here, we are simply gonna add stuff in. Now we should do some error handling. So in case we add overlays with the same name and stuff like that, but you know that's your little homework to do if you want. And this is the name. So this way we added an overlay, actually, which is okay because let's not call this while we are running the game. So this function will actually no, this is okay. So I was thinking this could be bad if we run the game and some object adds in some overlay, which shouldn't happen. But even like that, it should work because after all the game object ticking is done, we simply just iterate them. We are not doing it while we are iterating, so everything is safe. I hope it makes sense. So This is nice. So we also need some sort of way to differentiate when an overlay is visible and when it's not. Now, for now, we don't care, but we will add that in the future. You can probably imagine what we are going to be doing. We're going to add like a boolean in the UI overlay, said something like visible or not, and some way for us to update that while the game runs. So yeah, so let's actually create this overlay. In here, after everything is done, let's create scene add overlay. Let's just call this HUD, and this is gonna be a HUD overlay. And we're gonna initialize this with the scene, like that. Okay, so theoretically we should have a HUD now onto the screen. Well, I did say theoretically. What's the issue? Okay. Player. Player. Let's see. This is actually pretty weird. Does not take 5 arguments, okay. So 1 2 3 4 5 6 1 2 3 4 5 6. Okay, I get a feeling this is not the actual issue, so let's see what's the first error. Sometimes you'll get random errors because things failed at some point. And here, for example, we get an error in some file that we didn't even touch. So it means we changed something somewhere else, and that led to this issue. Now, let's think about it. What did we change? Well, we did add this UI overlay header. So let's comment that out, see if we have the same issues. And I think we do to some degree. So we see this compilation issue is in scene.cpp. So did we do something in here? Let's see. So let's comment this stuff. Because those errors look very weird, and so I suspect it's just some bullshit error cascading into everything. So, and guys, this is unedited, so you see here real development stuff. So source file UI overlay.cpp now. Okay, so in here, actually this is the first place where we got it. I think I may know the issue. We didn't really include here Raylib, which is pretty bad. Let's see if we can build this. And it turns out we actually got past the compilation. So let's put in the things in. You know, it's so annoying, it just doesn't give you the actual issue. It just gives you like sort of a shitty issue, right? And we see we have sort of the same thing here happening again when we added this into the scene. So not sure what that is all about. Oh, I know why this is all about. Okay. Let's build this now. Okay, so we have some issue here. Some function so we declared the function somewhere and it doesn't find the function implemented, right? So it can't resolve the symbol. Now I'm just gonna clean and build again because I have a feeling there's not actually an issue. And we were right, it was not actually an issue, it's just Visual C being dumb. And we can observe the fact that we actually don't have anything on the screen right now because we took it out in our little error hunting. Let's see if we have it now. And we do. Look at that. So let's make it a bit bigger. Bigger is always better, as we all know. So 64 by 64, and this should be all right. That's our health. Really nice. Now, when we lose, yeah. So we saw we actually have more health than 1, right? How much health do we have? We have 4. And we only saw 1 ship, and we want 4 ships, right? So what's happening is we are drawing the stuff. We are drawing 1 ship, right, in this iteration, right? And then we are drawing another ship there because it's on the same position, right? And what we want is the next ship to actually be offsetted here, right? Depending on what health we are, right? Because we are counting. So depending on how we count, we want this to be displayed differently. So we want to displace them horizontally. So on the x-axis, we want to add in like the count that we are on times the width. Okay. And we are actually going to add in some padding here in between those. And let's say it's like 12 pixels or something. And this is the width. So let's do that width. Actually size, because it's the same. So like that. And now if we run this, we'll see, 4 ships. And they're definitely a bit too large, actually. And we see we got damaged and we lost some of our health. And so for now, this is all I think for this episode. It's pretty long anyway, so we can stop here. It's just that I want to just correct this a little bit. Okay, this looks way cuter. It's probably too much into the screen, so let's reduce to 16 by 16 maybe. We are professionals, guys. Okay, so this looks okay. Next time we might add a little animation when health disappears. This is completely possible. And maybe some effect when we are dying and it's simply gonna restart the game or something, or just get us back to the menu. Okay, so this is it for today. See you later.